Hello, hello, welcome, and I'm so glad that you are here. Um, and today we are talking about Blazor architecture patterns, and I'm really excited to get into this with you. Um, we're going to be diving through a number of topics, and I see man, I'm so excited for this webinar. It's had such a huge response. We have a just massive crowd of people. I'm going to try to get through this content as quickly as I can. A lot of you are, I'm sure, planning or executing Blazor related software projects, and hopefully this helps you. ClearMeasure is a software architecture company, and our goal is for all of our clients' development teams to deliver world-class results and be self-sufficient, moving fast, delivering quality, running your systems with confidence. And so we're here to empower software development and make it so that you can do more in-house. And from our architecture retainer services, if you need a fractional chief architect or just need to be pushed in the right direction, help with some planning, that's what we do as a software architecture company. So we're going to get into this content. I like to peg around 30 minutes for the webinar. Sometimes I do go over, but as long as there's questions coming in, we keep on going after that, and the like. If this is the first webinar that you have attended in the ClearMeasure series, we do these pretty frequently, and so keep tabs on the next webinar. So today, if I forward, today we're going to talk about a few areas in Blazor architecture and just the patterns that'll help you succeed. Avoid some pitfalls. It's a brand new technology for a lot of people. It's a brand new paradigm for a lot of people. With the massive growth of our industry, just with the stats, we've had such phenomenal growth over the last 7 years. The number of developers out there has doubled in the next 7 years, in the last 7 years worldwide. So what does that mean? That means that half the people that are developers were not in the industry 7 years ago. And I'm sure for some of you, you're like, well, yeah, that's me. I've been developing for less than 7 years. And others are like, oh yeah, I've got a lot of coworkers who, are 7 years or less, because that's just the stats. That's just the facts. It's awesome. It's a fantastic industry to be in. It is so much fun. It's always better when it's growing, not when it's shrinking. But there's some things that were common pattern in regular business applications, I would say 15 years ago, that are coming full circle. And when you look at Blazor, some of those patterns drop right in super easy. And of course, if you weren't developing 15 years ago, you're like, well, I'm learning these patterns for the first time, which is totally normal. But we're going to talk about that. And if you are leading a team, if you're a lead engineer, if you're in an architect role, or if you're a development manager, then you're going to want to make sure that all the people that are developers on your team are equipped properly. And I think we've helped over 100,000 developers in over 40 countries and counting all over the world. And it's a joy to see developers succeed. And I started, my first development job was in 1997, and my entire career has been developing software, and now it's just a joy to propel developers forward and to see them just really love work and really just delivering excellence. A few resources just to get past. This is not related to Blazor, but my latest book was put out November-ish, November 2019, .NET DevOps for Azure. A lot of these I will touch on, just getting your environment so that you can move fast. Your cycle time is really short, so you can make a change and get it down the road to production and just iterate super fast. Even multiple production deployments in a day. That's it used to be for just some of the big tech companies, but now it's for everybody, and the tooling is there, and there's no reason why it shouldn't just drop into place for you. So I'm going to give everybody that's on this webinar, I'm going to give you a free electronic copy of my latest book, .NET DevOps for Azure. Just send me an email or put it in the chat. My assistant, Rain, will be looking for that, and she'll make sure that you get it. If you want a print book, you can get it on Amazon or anywhere books are sold. And make sure to go to clearmeasure.com/webinars just to keep tabs of what's coming up and recordings of past webinars. By the way, if the recording of this webinar was sent to you from a coworker who watched it live, I will honor that offer of a free electronic copy of my book. Another resource that you may be interested in is the Azure DevOps podcast. I host that weekly. We are over 100 episodes now, over 2 years running. And it is for people shipping software with Microsoft technologies. And we go anywhere that goes. Now, most of the time, we're making kind of an assumption that you're going to be running your software in Azure, and that you're interested in operating it well, which is the whole theme about DevOps. But it's not required. So you can go anywhere podcasts are heard. Now, overall, with the Blazor application, it is a .NET Core web application, all right? So the DevOps pipeline that is appropriate for a ASP.NET Core application is completely appropriate for a Blazor application, regardless if it is server-side or WASM. For the purposes of this webinar, because Blazor is such a broad topic, for this webinar, we are going to focus on Blazor server-side. Then an upcoming webinar, we're going to focus and dive deep on WebAssembly and some of the key differences there. Okay, so today's webinar is focusing on Blazor server-side. Now, this is a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure Pipelines and Octopus Deploy, Redgate, SQL Change Automation, some other complementary products. And if you're just adopting Azure Pipelines, by the way, your DevOps environment is not going to be just Azure Pipelines. It's not going to be just one product. To really get all the capabilities that you need a collection of products. You need some testing frameworks so that you can have a cascading, a minimum 3 level of test suites. You need multiple environments. You need to provision and change some of the environment settings. It's not just deployment, it's also operating, figuring out what the runbooks are. When you need to scale up and scale down certain resources in the environment, you need to have settings and capabilities to do that. So deployment is kind of like, that's your ticket to the game, is deploying. But then you need to operate and monitor, and there's so much going in. Anyway, here's here's what the full poster looks like. It's obviously way too big. You're not going to see the font, but we'll send you a high resolution PDF if you just request it in the chat or send me an email. Now, all right, high level. Again, Blazor is just a ASP.NET Core app. So you're gonna right now it's gonna be .NET Core 3.1, and the same rules apply with other .NET applications. You want one Visual Studio solution per Git repository. So your Blazor app is going to go in its own Git repository. You want essentially one logical versioned software application to be in one Git repository. If you're coming from other repositories where you had entire trees of source code, you want to make sure that the Git repository has one versioned software application. Now, if you have 2 different Blazor applications for different constituencies, but they kind of use the same core libraries and same objects and same data access and all that, perfectly fine to have 2 Blazor applications in the same Visual Studio solution, all in one Git repository. But if you've determined that those are separate applications and they live a separate life and they have separate dependencies and they get deployed on a separate cadence, those are 2 different applications, and they need to be in separate Git repositories. Okay. All right. Oh, and by the way, this diagram is in my book along with other things there. All right, let's talk about the architectural differences between ASP.NET and Blazor. Okay. And again, for this webinar, because Blazor is so big a topic, we'll never get through it. For this webinar, I'm going to focus on Blazor server side. The next one that we do will be on WebAssembly. So I'm kind of splitting it because it's way too much content. All right. And I didn't want to suck up all your time. I want to get you in and out because you all have a busy day, I'm sure. So the actual client that runs in the browser is a JavaScript file that you will never even look at. You don't care about blazor.js. And that's a client you don't even have to write, and it runs in the browser. So the code that actually runs in the browser is already written for you. All of your code on Blazor server side is going to execute on the server. So all of your code can be C#. Now, if you have a little bit of custom JavaScript and you're pushing out some JavaScript, that can be an exception. But there are so many controls already that have all the behaviors that you need for so many business applications. It's very feasible that 100% or darn near 100% of the code that you write can be just C#, Razor syntax with HTML and CSS, and it'll all run on the server. The connection between the browser and the server is SignalR, and we're going to talk about how that SignalR connection works. Now, if you deploy it straight to Azure, then WebSockets is not going to be on by default. If you just go to the free tier on the hosted plan and then kind of up it, you're going to be defaulted to 32-bit, and you're going to be defaulted to WebSockets off. Now, SignalR will automatically be hosted in your web app, in your Blazor web application. When you deploy, it'll automatically be hosted. But if your web server, in this case Azure websites, if WebSockets is off, it's going to use SignalR long polling. So when you look at your monitoring, you're going to see just requests per second is constantly going. You're thinking, man, am I getting a lot of traffic? What's going on? Well, no, you're not. It's because WebSockets is turned off, and SignalR is going to fall back to a long polling mechanism where it's just asking, hey, is there a message? Is there a message? And every one of those is a new request. And so what you want to do in Azure, like you see on the screen, is you want to turn WebSockets on. And then, of course, for memory, you're going to need more memory. You want to switch that over to 64-bit. Okay. Now, ARR affinity, we have set to on. If you only have one web server, then you can ignore this. If you have a low volume application, you can ignore this because you're always going to be going back to the web server anyway. However, because everything is running on the server and your session and all of the state of the screen is on the server, a client can't be hopping around from one server to one server. If you have ARR affinity off and if somebody accidentally closes their browser and then reopens their browser and clicks on a bookmark or whatnot, it could go to another server. You're just starting up a new session. Whereas Blazor is going to attempt to reconnect with an abandoned session if it can. Your smartphones. So when you use your browser on your smartphone, sometimes you open up your browser and you've got previous tabs and you see a picture of the website, but then it's trying to go back and refresh that site. We'll talk about Blazor session management in a little bit, but the second you have a second or even a possibility of a second web server, you want to set ARR affinity to true so that that client always gets routed back to the same web server. Now, when scaling up and down, what that means is that if you have one web instance that's starting to get overloaded and so you add a second or a third web instance, you're actually going to have to force some of those clients to reconnect so that they'll get routed and distribute to the multiple web instances because they're going to be locked into that server. So those are some things to keep in mind. And we've already in the Blazor landscape, we've been deep into the Blazor ecosystem and helping clients. And we've been through some really hairy and high scale Blazor situations. We understand some of the situations that you get into, and that's one of them right there. It's going to happen. As soon as you get to that second web server, you're going to have that matter to deal with. You're going to have to think about that. All right, let's talk about the structure of a Visual Studio solution with Blazor. Again, I assume that every one of you has seen some of the quick starts or some of the getting started videos, so I'm not going to cover any of the basic information that you can get other places. These are all lessons from actual projects of actual applications that have gone to production and have real usage in production, real lessons learned for what's different about this new technology and what things you need to think about. And of course, the strength is the same with .NET. So there's a lot that you don't have to think about, which is probably what attracted you in the first place. Now, on the right hand side, This is actually I pulled some examples from a real high scale multi-event car auction platform. Okay, this actual application runs auctions. Okay, and this is the real solution structure. Now, for for intellectual property purposes, I can't give you the code or just kind of really go into detail, but this runs auctions. So let's think about the scenario here. We need to list the cars, and the cars need to have pictures and whatnot. And there's a order of auctions, and then people register to be a buyer at the auction, and they're going to do a bid. And an auction, if you've never been to an auction, think about from a business standpoint, this is high intensity software. This is software where delays aren't tolerated because you have an auctioneer and projecting it through the web. With a lot of these car auctions, you can bid online as well and kind of watch it on a TV or a video stream, but it needs to be real time. Whereas when you make a bid, the auctioneer and the people rolling the cars through, they need to know that the bid came in. And somebody else makes a bid, you as the bidder that just lost out, you need to know right away. Okay. So think about a traditional web application where you just kind of pull up a page. No, you got all kinds of things happening. Kind of some of the elements of a trading system, not as intense as a NASDAQ trading system, but this is high intensity software because these are high intensity, fast moving events. So any kind of latency is not our friend. Okay. And so Blazor, which with the richness and the constant connectivity, was a real asset in this particular software system because we don't have to keep on calling back to web services. With SignalR, we can push from the server up to the screen. And so the dependencies of this solution structure are on the left. And this does use the Onion architecture family of patterns for dependency management. If you're not familiar with Onion architecture, just do a Google search. It goes all the way back to 2009 when the kind of original posts were written outlining the tenets of Onion architecture. And the basis is the core project. When you look at it in the block diagram on the left, the core project has all of our, if you're using domain modeling, it has all of the aggregates with the entities and value objects and relationships, or it has all of your business objects. All of the classes that model the domain of this software are in the core library, the core project. And the core project itself has hardly any dependencies. It is just plain Jane vanilla C#, and a subset of the base class library. It doesn't have any dependencies. It doesn't even know what a web application is. It doesn't know what SignalR is. No dependencies. This is not a project where we add NuGet packages to. It is just plain C# classes, and that's where we implement our patterns. So if you were to make a command line application, a mobile application with Xamarin, if you were making this into a WinForms or WPF application, that core library could be used as is, no changes, because it doesn't even know any of the UI technologies we're using. That's like one of the core tenets of Onion architecture, is that core project is absolutely clean and totally portable. In fact, in .NET Core, we like the core project to be a .NET standard project as opposed to a .NET Core runtime project, just to give it a little bit more teeth, just so that every developer, if they accidentally forget and they try to add a NuGet package to it, it's not going to work, because this is .NET, or only NuGet packages that are .NET standard, which whittles it down a lot, but it kind of gives it some teeth. Like, we don't want all these dependencies on this project. We want this to be a clean, portable classes. And then you can see the tree from there. Notice we have a database project kind of orphaned at the bottom because we want to put we have a SQL Server database. We want to put our database migrations in the same Visual Studio solution. Notice that we have 3 levels of automated tests. We have unit tests, integration tests, and acceptance tests, kind of cascading there. Okay. All right, just give you some context of everything else we're doing. People are making bids in the actual auction garage with the cars rolling by. There's an auctioneer calling out. There's a camera being live streamed up to the internet. And there's a few VIP buyers that are kind of in person, people who buy, you know, a lot of cars at auctions and whatnot, and they're in person. But at the same time, there's, you know, collectors who are bidding online, and so, you know, we need low latency. We need to know things right away. So that's a context for this, just so you understand the nature of the application. Now, memory management is the next category I want to talk about. This is going to affect your services collection, how you do your dependency management. I have a preference for the Lamar IOC container. And so Lamar was a .NET Core, essentially a .NET Core rewrite, or a child of the structure map IOC container, which was one of the earliest .NET and one of the most popular ones. And so Lamar, by chief author Jeremy Miller, essentially the child of structure map is called Lamar, Lamar. That tends to be my favorite. It seems to be the most automatic, where it just works. You don't have to do a lot of configuration, and it works the way you expect it to. However, even if you're using the built-in dependency management, you need to know these key differences. Now, there's 3 different scopes with our services collection, which is our inversion of control container. There's singleton, there's scoped, there's transient. Now, for a long time with regular web applications, scoped was scoped to the life of the HTTP request, which is great for web services, for MVC controllers, all that. In Blazor server side, the life of the web request can last hours because of the nature of Blazor. There is a web request to, hey, give me the base HTML and give me the blazor.js and connect my web socket, just connect it, and then it stays there with an open WebSocket. And so while not technically HTTP is not going to stay open forever, but so that's not technically true, but scoped is the life of that connection, because we're going to connect a WebSocket, and the WebSocket can stay open for as long as they have that browser tab open. So that's a key difference. When you think about all the things where you were using scoped in your dependency management, that's a key difference. You need to think about that, because all those objects wrapped up in it are not going to get automatically disposed and cleaned up with the garbage collector after the end of one of your button clicks and after your code finishes running, because every object that's referenced from whatever screen you're on is going to stay around. Okay. Also, there is abandoned session management, and Blazor keeps those open for around 5 minutes. Now, there's a lot of talk on forums, and they may change this, and I actually hope they change this, because I think 5 minutes is too long. Just in practice, I think 5 minutes is too long. But for instance, on your mobile phone, someone pulls open a screen, looks at something, and puts it back in their pocket. They're not actively on your site. And for 5 minutes, what the framework is doing is trying to balance someone pulling it back out of their pocket, looking at it again, and then preserving the state that was there, as opposed to reloading the Blazor application, then going to the home screen and then having to navigate back through. Okay. So it's a balance that you do, because you don't want, as soon as, if the WebSocket is interrupted, even for like half a second, you don't want it to immediately throw away everything, because the internet has flaws and it's not 100% purely connected. And so it does need to be resilient to drops, and then people coming back and not having to restart the application where maybe they've navigated a few screens in. And not all the screens are going to have unique URLs, because deep linking is really up to you. It's up to the developer. It's not automatic. So keep in mind that right now there is a 5-minute timeout. So if you have a screen that loads up a lot of memory, and someone has it on their phone and then they put it in their pocket, and that's a common use case, you're going to keep, essentially, objects are not going to be garbage collected for 5 minutes, which is very different from ASP.NET. Okay. So if that's an issue, then you might have to more explicitly get rid of memory and clean up memory, things like that. All right. Now, the entity framework data context is something to really think about. And if in a Blazor application, if you use services.add context for whatever your data context, your DB context class is, that will add it as scoped. And if you're using another IOC container, if you just add it as scoped, that's the same thing. That means that the same DB context will be used for the life of the user's session, again, because we're connected with a WebSocket. So with regular web applications where every request was creating a new DB context and then throwing it away, memory was being cleaned up just like that. This is very different and could catch you by surprise. So just be aware that that's happening. And in cases where you need that whatever objects loaded up by the DB context to go away and be cleaned up, well, you need to code that on your own and make sure that that is being disposed of properly so that the garbage collector can do that. Now, I do want to, before I actually go into this next pattern, I do want to talk about resource selection. I'm going to talk about Azure SKUs later, but IIS and the garbage collector work based on memory pressure. And while .NET Core, so many things were rewritten, the fundamentals of the CLR and garbage collecting have been there since way back when .NET 1.0 came out in 2002. And if you haven't read Jeffrey Richter's book, CLR via C#, then you need to, because that goes into the guts of how .NET works. And if you don't know how it decides to run the garbage collector, then you have no idea when your objects are actually going to be reclaimed so that your memory footprint can go down. And one thing, when scaling up these Blazor web applications, the ticket is not to go with a massive instance size, but to go with more instances. Okay, if you reach for larger instances, then you're going to get up to 14 gigs of RAM on that one web server, and IIS and .NET are going to say, oh, I don't have any memory pressure. Why do I need to waste CPU cycles running the garbage collector? I don't have memory pressure, especially with a 64-bit process. And then you're going to be up at 10 gigabytes memory, and you're going to be thinking, what's going on? Well, it's because there's no memory pressure. So the CLR doesn't have the incentive to run the garbage collector, because it's like, I got more memory, but the memory still has weight because the process is still having to go through. And so if you actually, that's where constraints can be enabling. So if you actually use maybe just a few more instances, but a smaller instance that doesn't have as much RAM available to it, then the garbage collector will run on what is a more normal frequency and clean up that memory, and you'll have a more stable experience. So that's something to keep in mind when running this. Now, let's talk about patterns that you absolutely will need in a Blazor application. Actually, this is regardless if you are Blazor server side or WebAssembly. This is really any application. You need a hub and spoke pattern. Now, if you've done API controllers with Web API or MVC controllers, you're used to working with a hub and spoke pattern that Microsoft has given you, where the hub is the iController interface, and the spokes are all the various implementations of iController. If you have 100 screens in your application, you have 100 spokes, but the framework has one hub, iController, that it routes all these requests to, and then the controller base class says, or the routing says, what actual concrete instance should I route this to? And then there's some helper in the base class. So you need to, with Blazor server side, you need to give yourself your own hub and spoke pattern, where you're going to, let's say you do have, your application grows to have 100 screens. You need all 100 of those screens, if you were to draw them on a whiteboard, all communicate to one hub, to one interface when asking the application what to do. And the responsibility of a screen, regardless of what UI pattern that you use, I love MVC, where the view is presentation, where the controller is to discern the user's intent, and then the model is to represent the data. The controller, whether it's a dedicated class or controlling logic, is discerning what the user is asking for. And I love the CQRS pattern where we put it into a class that is a message class that is a command or an event or a query. Let's say the user says, hey, I need to see some data. Easy, it's a query. So the user is asking for, let's say, asking for the cars that are going to be sold in the auction. So let's say a car query. And now at the top here, we're actually refreshing some data, and we're looking at, hey, what car auctions, what car auctions are scheduled in a particular showcase, in a particular event. And so we have codified the user's intent into a message type, which in the first line of code here, auction by event ID query. And then we're sending it to a bus, okay? We're sending it to a bus. Now at the bottom, you can see auction by event ID query, and it is just a regular DTO. So codifying the user's request. And then of course the handlers, what you think of, if you're used to using the repository pattern where there was a class per domain root, aggregate root with multiple methods. Well, now you have a query handler that is its own class. So you have really small classes, and they're messages and message handlers, or you call it request and request handler. Now, I will assert that every one of your Blazor applications needs a bus to govern the logic in your, whatever your hub is. And so the bus pattern is a fantastic implementation of a hub and spoke pattern, okay? Where the command or the query or the event, you send it down the bus, and you can have all these listeners, and then ultimately a handler. A handler, you can have only one. A handler ultimately handles it, but you can have as many listeners to say, oh, that's happening. Well, based on it happening, maybe I need to do something else. And yes, the code really does talk to itself, talk to each other. It sounds exactly like that. So we have an interface, iBus, and two methods, send and publish. Send is, hey, here's a query or here's a command, and it actually needs a response. And publish is your application eventing. Hey, this is happening. And so a sample implementation, actually, this is the implementation from the car auction application, is we're sending it down, we're doing a little bit of logging, but our bus is actually wrapping the mediator library, which is the chief maintainer on that, Jimmy Bogart. He was actually a guest on the Azure DevOps podcast a few weeks ago. So we're wrapping the mediator library, and then we're adding on some cross-cutting concerns. One of those is sending what is happening to application insights so that we have telemetry. You can see that sync.record call line. We're saying, hey, guess what? I just did this. Let's record that I just did this. And on the publish side, I'm going to come back to this later, but on the publish side, these are events. These are, hey, these things happened. It's not, you can't prevent it from happening. These things happened. And now I just, any other code in the application that needs to know that it happened can know. You don't, in a Blazor application like this, you do not want to make a lot of use of multicast delegates, because that becomes just a tangled web of dependencies and the garbage collector. You're gonna kill your memory management, because things are not gonna have clean reference breaks, and you're gonna have memory leaks all over the place. And this is not just Blazor, this is WinForms, WPF. This is actually one of those things going all the way back. The UI frameworks use events, and those are events that are designed to be used in the view. But once you get below the view and get into your application, you do not want to be using multicast delegates or setting Lambda properties. That is just a recipe for disaster. You want to have observer patterns. You want to have listener patterns, visitor patterns, bus, chain of responsibility, all these different types of hub and spoke patterns that allow an object to go down a particular choke point, a particular pathway, and for different code types to different classes to kind of listen and observe and then get their cues from that. All right. So we're going to come back to the broadcaster, but just for eventing, we do need to broadly publish what is happening. And I'll come back to some of those scenarios. Okay, let me talk about the telemetry advantage. When every navigation, every button press, even if you key off of someone clicking into a text box, the user has some type of intent, or the user just did something. So you wrap up what the user did or what the user's asking for in a DTO, in a plain old C# object, and then you send it down the bus. Okay. Now, from a operations perspective, when our application is running in production, we got lots of car auctions going on. We got lots of bids being placed and buyers registering and looking at cars. We kind of want to know what's going on. Which of our auctions are the busiest? Are buyers placing bids? What's our bid density? What are we encountering any latency? Are people having to wait in order to place a bid, or are they getting notified properly? So the record call button, this is our code inside that telemetry sync class. We are recording the custom event with application insights. And what we're doing with the request is we're taking the full name of it and we're creating a custom event. And then you see that line of code, add property values. Now, this is a little bit of, it's just a method, does a little bit of reflection, rips through every property. And we're actually adding to the custom events dictionary every property name and every property value on that type, whether it's a command, a query, or an event. And so what that enables us to do in application insights in Azure on our dashboard is boom, automatically across the entire application, regardless of what feature it was, screen it was, function it was, automatically the entire Blazor application is instrumented, soup to nuts. Everything that the application can do is automatic. We don't have to sprinkle this code all over our application. Even if we have 100 Blazor screens, the Blazor screen has codified it into a message, and we've instrumented all of it. Okay, now let's talk about user interface eventing. Okay, because you've got your screen up, and if I click on something on the left side, or shoot, even if I hover on something on the left side, maybe some other part of the screen needs to do something. The canonical stateful eventing is cut, copy, paste, or drag and drop. Or if I have a tree view of items and I select something on the left, maybe it needs to kind of pop up in a properties pane on the right. Again, these are not the web applications of the last 10 years. These are rich, stateful applications that happen to run in a browser. Okay, the screen comes up and someone looks at it, and things move. Actually, someone could come in this car application, literally, this car auction. Someone pops up and monitors the auction. They pop it up, they put their hands behind their head, and they watch it, and they see as the bids come in, and as the cars come up for bid, and as the cars have a winner, and they don't even click on the application at all, because it's just kind of changing in front of them because the status of the data is changing and we're pushing information to them. So these are a totally different breed of applications, and just so much power. So many people would prefer a desktop application if it weren't for the deployment model, where you put out a new version of the application, but now you don't know what version of the application your users are running because you're not in control of when they accept the new version. Well, if the application and the application version is delivered via a URL, now all of a sudden the development team is back in control of users adopting the latest version of the application. But guess what? It's a rich, stateful application. The meteoric rise of smartphone applications, everybody wants a rich, stateful application that remembers what they were doing. Everybody wants it. Nobody wants a stateless web application. It was just a constraint as a developer community we had about the deployment model. So the UI in Blazor is stateful. Don't plan on the user refreshing their browser. You actually don't want the user to refresh their browser because it's going to orphan the connection that they have and start a completely new session. And then their memory is going to be on the server and they're going to be using up more memory. And so don't plan on browser refreshes. And if you don't have any experience with any kind of desktop applications or serious SPI applications with some of the JavaScript frameworks, then go study those or talk to a peer that has and bring back those patterns. And a lot of what I'm talking to now is that as well. And then finally, before we dive into some code around eventing, you are going to factor your Blazor screens into many components. Okay. Don't just paint a bunch of HTML. You want to reason about the structure of a screen. And if you have a left nav, boom, actually, you want the whole screen to be the shell. That can be your master layout, and the dividing line to be owned by the layout. Then that left pane, well, there's another component. Oh, does the left pane have a top and the bottom? Well, there's two more components. The main screen, do you have a main area? That's a component. Do you have maybe a properties pane below? Just start thinking again about how desktop applications are structured. You're on a Zoom webinar. Zoom is desktop software. It's stateful, rich software. And think about it. You've got the main display window, but then you've got the little toolbar where you can adjust your audio settings and all that. So there's different areas of the screen, very different from how we think about laying out screens as pages, as if they're documents. In Blazor, just get the mental model. You're not laying out screens as pages. You are laying out screen regions, okay? So you're gonna factor your screens into many components. All right, here's an example of a section. Just wanted to have something digestible. And I'm not going into the basics of the component model because there's plenty of content out there. But because you have a screen that needs to paint itself and then load data, there's a little bit of dynamic that you need to be aware of. So we have a screen that is going to show essentially the details about each of the cars that's available in the auction. And then there's going to be, actually this particular screen is showing one car, okay? But this component can be embedded over and over and over again in the listing screen of listing all the cars. And then the bid dialog can own the bid button and the dialog that pops up to actually record a bid. Now, what's going to happen in your browser if let's say you have, I don't know, 100 cars at the car auction, and you're going to load the listing screen. This is what's going to happen in your browser. Now, this is just in a kind of local development environment with a whole bunch of data, so forget the timings because it's going to be different. But from an order of events, what we have is Blazor's behavior in pushing out DOM changes to the browser. And so if you have 100 of these cars, then you are going to have 100 of these SignalR binary messages being pushed out to the screen. Because again, we're not painting the whole screen in one fell swoop. It's kind of like Facebook. Almost everybody uses Facebook now. The same thing with Twitter. The sections of the screen, these are at this point regular SPA patterns where you load the structure of your screen and the user saw, oh, it was responsive, the structure of the screen, but then certain sections kind of have something moving so that you know it's still loading. Because behind the scenes, this is happening. The server is kind of pushing out certain sections and the browser is receiving DOM changes, and you can track in the network tab of the development tools, you can track the different frames, as they're called, that are coming in for the DOM changes. And so I encourage you to measure what your applications are doing just to understand, because one of the interesting patterns, you want it to feel faster than it is, because you don't want to wait for all 100 cars to load. And so here, this is one of the simplest patterns. One of the simplest patterns here is, and this is in Blazor code, we have all the items. You know what? Let me take 10. Let me call state has changed. Instantly, Blazor is going to get those 10 up to the screen. And then while it's doing that, the rest of the items are pushed there and state has changed again. And so the rest of the 100 will start flowing through, so that by the time the user takes their mouse and grabs that scroll bar or starts doing page down, it actually pages down to see 100 cars. But if you don't do that, well, now it's just like this annoying half-second lag that is perceivable. So you can get rid of some of these perceivable lags just by doing simple things like that. All right, let's talk about a case of pretty much everybody's going to do this. When do I have a certain section of the screen refresh itself? If this is a stateful application, the user's not refreshing the whole page, then we need to have a certain section of the screen refresh itself. Well, this is a super easy pattern to accomplish that. And we can have a timer. We could say, you know, every 10 seconds we need to have, or every 30 seconds, every 90 seconds configurable. And we can just have a timer. And this can be in a component. So you can just slap this component on a particular screen or even in the master layout. And now, boom, now I have a refreshing section, and all it's doing is creating a timer. And then upon that increment, it's saying, hey, this happened. What happened? It's an event. So it happened. Events have already happened. You can't stop them. It already happened. So the name is called refresh timer triggered. It is a fact that the refresh timer was triggered. And so anybody that cares to listen for that, they can listen to that notification. And all this Blazor component had to do was send that event to the bus. Okay, easy. Now, let's say that there's, you know, two different components on the screen. They don't need to know that the refresh component exists in Blazor. They don't need to know about each other. The only dependency that they have to have is to know about the type refresh timer triggered, which you know, would be in a messages library or namespace. And so for a component to be notified, all it has to do is implement the interface that the bus has defined called iListener of something. So iListener of refresh timer triggered. And then of course it can listen for as many events as it wants to, implement a method, decide what to do when that method fires. It's as simple as that. And when a component is created or initialized, all it has to do is register itself with the bus. It says, hey, I'm here. I'm here. I'm a live listener. That's it. And it is a super scalable pattern for UI eventing, where different components don't need to know about themselves. They don't need to define an event and then subscribe or plus equal to an event, because that creates tight coupling all over the time. All they have to do is implement these listener interfaces, define your event types, and it's a really great way to follow the open closed principle as well, one of the solid principles. Now, let's get into another juicy Blazor event. And actually, this one would be broadly applicable regardless of Blazor server side or Blazor WebAssembly, and that is broadcasted events. Now, what I'm talking about here is where you're successful and your application is running in multiple places. Now, Blazor server side, this would be where you have your second web instance where all your code is separated into different processes. So there's no possible way you could have a server-side eventing model because you got different processes running. You got a web form that's growing. And of course, on WebAssembly, every client is running another instance of your code. So there's no way you could do any kind of C# based eventing. They're all over the place. So you got all these people who are watching this car auction and a bid comes in. How do we notify the other people that a bid was just placed on a car that's currently the active car being auctioned off, and that's the one that they're watching on the screen? Because if you're looking at the car on the screen, you want to see what the current price is, right? And that price just needs to update. We don't want them trying to update the screen and reload the application. So we have to push that information to them. somebody, one of the people placed a bid. Okay. And so what happened? Guess what? A bid was placed. That was the event. So we hook into our bus in this case, a notification broadcaster. And the responsibility of this is to take events that meet some criteria. And in this case, all they have to do is be tagged as a marker interface, broadcastable notification. So if one of the events in the application happens to implement the marker interface broadcastable notification, that means that that event needs to be distributed to all of the clients. And so then what we do is we turn that C# event into a SignalR message. And then we have the SignalR hub essentially push it out to every SignalR listener, which, by the way, is every Blazor user. Okay. So that's what we do here. We use a strongly typed SignalR hub via the iHub context. And we don't need to send it out to every user because you got 10 car auctions going on at different times around the country, or sometimes the police departments auction off old cars. So you got all these auctions going on all over the country. We don't need to notify every client that a bid was made. We only need to notify the clients who were watching the auction. And in fact, you could say we only need to notify them if they're watching that particular car. But if the screen has, lots of cars on it, whatever level the grouping is, you don't need to notify everybody. You need to notify a subset. That's where the SignalR groups come into play. And in this case, the groups are by auction. It's like, hey, I'm watching a particular auction, so my client needs to be receiving the events for that auction. So this is how we broadcast it out, but we just hook into the bus. So again, our Blazor code files, those Razor components, they don't have to mess with any of this stuff. We do it in one place in the application, and because we're going to end up with dozens of events that are happening. And then some of them represent a transaction where all of the various clients need to know about it. And so we slap on a marker interface of broadcastable notification. We wire this in with the bus. Every single command, query, and event is going down the bus. And then some of them need to be broadcasted. And this is what does it using SignalR. Okay. Now, let's transition and talk about testing. You need a minimum of 3 levels of test automation: unit testing, integration testing, and full system testing. I'm not going to talk about performance or scalability testing today, but you also need to have a solution to that because you want to know that your application is going to work well. So one of the things you can do is you can take one of your acceptance tests and you can set it running overnight. Just run over and over again, overnight, and see how many hours it takes for your application to crash. I guarantee if you've never done this before in a brand new application, there's always going to be something, right? There's always going to be something. It's a brand new application. It hasn't been hardened yet. So that's an easy test to ferret that issue out. If it's not tested, it's broken. And there's different levels of automated testing can help you do less testing in production or have your users do less of your bug identification. Now, for Blazor components themselves, the best library that I'm aware of at the time, and it works out really well, is called bunit. And that enables you to, with InUnit or XUnit, it enables you to do a arrange, act, assert pattern. And I've cut off the arrange because it was just too much cruft to be looking at on this screen. But it enables you to do an arrange, act, assert pattern, starting with a Blazor component, a Blazor code file. And what we're doing is we can set the parameters, we can tell it, hey, render the component based on what you're doing, and then we can find the different elements and make sure that what happened was what we expected to happen. And we can either include different parts of the application or we can mock different parts of the application and assert that certain parts of the application were called in the right way. And so bunit is the library that you need to be using at this point in time for making sure that you have tests around those Razor files, around those Blazor components, and because you definitely want to use it. Now, if you find that it's just really hard to write tests, that means that you've got way too much code in your Blazor files and those Razor components. Those Blazor components need to be small, and they should have almost no logic. You want to factor out the logic into the rest of your application. You also need to be doing full system acceptance tests. Now, the good news is that Selenium, which has been around for a long time, is perfectly suited to do full system acceptance testing for a Blazor application because it's still HTML DOM based. We can look for a particular element in the HTML DOM and we can interact with it, which is what Selenium does. So because Blazor uses HTML, CSS, and the like, it really does. It works fabulously. And with Blazor, because it's not a web refresh, you will have to implement some type of sleeping algorithm based on your application. But if you fully implement eventing, then you can subscribe to some of those events in your test harness as well, okay? Because your test harness could easily be a SignalR hub connection consumer, and it could wait until the event comes and then spring into action, and that's more deterministic. But big sleep may be, I don't know, a quarter of a second, just as opposed to doing things immediately, and that's configurable here. Hey, do we need to wait a quarter of a second or not? And that's not as deterministic, but that's just the nature of it. So you see those here. Okay. So you do need to do full system acceptance testing. Now we are almost done here. I want to talk about operations and monitoring. You are going to run with more memory. Blazor server side, all the user state is on your server. So think about a mainframe application with a terminal. We're streaming out the UI. That's kind of the architecture. You're going to use more CPU. And low latency is really, really important. So if you have really slow internet connection, remember, when you click a button, you're going to have multiple round trips to the server. Now, those round trips are going to be tiny, tiny, but because you have multiple of them, latency is not your friend. And finally, you want to instrument what the people are doing. If you use hub and spoke, if you use that bus pattern I just showed you with CQRS, and instrument every message that comes through, then you're going to know exactly what's going on. This is my current favorite SKU for the hosting plan, the P1 V2. It's got 3.5 gigabytes of memory, which is enough because Blazor does need enough. But I found going up above that causes the garbage collector to have a little bit too much breathing room and run less frequently. But your mileage may vary. You need to test that out. Also, you can test out your manual. You can test out your SignalR implementation by just scaling up to multiple instances and get off your Wi-Fi and just pull out your smartphone and connect through your cell phone provider, and you'll probably be routed to the different instance. This is an example. This is actually a real example of application insights looking at events. And this is the growth of the car auctions just over the last, 6 weeks or so. And I have selected the different events. Every one of these event names is a C# class that went down the bus. And so, and the green check marks across the top are deployment markers. These are when this particular production environment was deployed. And so you can see any change. You can correlate, like, hey, did we do a deployment and just things started going badly? You can see when we did deployments. And then you can actually go to the events view in Application Insights and select the events that you care about and know exactly how busy your application was and what the growth trajectory was. So this is the power. You get this telemetry for free just by putting those patterns in place. Don't do just tons of logging, this iLogger stuff in your Blazor application. Implement this pattern and push it as a custom event into Application Insights. Yes, you want to do the iLogger for local debugging and whatnot, but once you get deployed to production, you need to set that logger to be at the warning level. You don't want all that mess. One, it's going to slow down your application. You don't want all that mess. You want to set it at warning. If something goes bad, then you want your iLogger stuff to come through. But other than that, iLogger is for downstream environments, not production. And then just what the users are doing, you push them through the application insights as custom events, and then you can pull them up in your dashboard, kind of like this, based on which events you care about, and then infer what the application is doing. All right, so we've actually used up the full hour. And again, email me for the free book. And we have really helped out, really loved helping out our clients get their first Blazor applications out from under them. This information comes from real code, real project work that is in production. Lessons have been learned. This is not theory. And so, hey, plan your Blazor project. Call us if you need any help. As an architect company, we don't want to do your project. Okay. You're doing your project. We're not a dev shop. Okay. But we want to make sure that you go in the right direction. And for some clients, that's just a small retainer where we're talking through and just giving you advice and asking questions and making sure that you're on the right track. And for other clients, we get alongside and help them push through a particular issue. So good luck with your Blazor projects. And if you think that a conversation, even simple as a conversation, even if you don't have any budget, just call. I love talking to developers who are doing really cool things. Give us a call, and I hope this was helpful. I think I used up all the time. So send me an email if you have any questions, and I'll make sure that I reply to anybody who sent in an email. So thank you so much for your time. I want to be respectful of that, and happy Blazoring.